Hi everyone, the next thing we're going to tackle in this section is solving power equations. So this is going to be a lot like when we solved quadratics with square roots, but we're just kind of broadening the types of equations that we can tackle. So just to get us going, we'll start with one that's really similar to using square roots to solve quadratics, but this one is x cubed, so we'll use a cube root to solve. So we can take the cube root of both sides. And in this case, 12 is not a perfect cube, so we're really done at this point. We don't have to go any further. If it is a perfect cube, please continue, but here we don't have to go any further. What I would like to get out of this one, though, is to realize that it's only when we have even roots that we need to use the plus or minus. So if you're taking a cube root or a fifth root, etc., you do not need a plus or minus on that. There's no confusion where when you cube a number, the sign disappears. The sign will actually stay exactly the same. So just go ahead and take the root and you're done. They're actually a little simpler than our quadratics were. Okay, so stepping it up just a little bit, we're basically going to be doing reverse order of operations when we have multiple operations. So this time we have the fourth root going on. We also have multiplication by 4. The multiplication would happen last in order of operations, so it's the first thing we get rid of when we solve. So if we divide both sides by 4, we get x to the fourth equals 3, x to the 1/4. And then again, recognizing that that 1/4 power is a fourth root is really important here. You don't have to write it that way, although you can if you'd like to, but recognizing that I think really helps with the thinking and realizing that you need to raise to a fourth power. You could also get there though by recognizing that the 1/4 power and the 4 multiply to be 1, so that's going to cancel out. Remembering the multiplication rule for exponents is what we're dealing with. So either way, this is going to leave us with x to the 1. And then 3 to the 4th is something that we can actually evaluate, so you should. If you get something that you can go ahead and calculate, do it. Let's see, 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So that's going to be our answer for that one. Next one, x to the 2/3 minus 2 equals 2. So again, with the reverse order of operations, I do have a 2/3 power, but I also have a subtraction, and subtraction happens last in order of operations. So it's the first thing that I'll eliminate. So I can say x to the 2/3 equals 4. And again, you have two choices here. You could either think about this as roots, rewrite, or you could try and use the product property for exponents, the multiplication property, and say, I need to raise everything to the 3/2 power. And that works, and it is efficient. Here's my one concern with that. I think it would be easy to not recognize there that you're taking a square root, and when you take a square root, you need a plus or minus. So this is one of the reasons that I sometimes kind of lean towards rewriting it, even though it might take a few more steps to get all the way through. I think it'll save you from possibly missing that. So if I'm looking at this, I would say, okay, that's the cube root of x squared. And you can either square first or last, it doesn't matter. Either way, you should get to the same answer. So we'll try it here. I said favor the other way, so let's go ahead and try it that way. But it will work either direction. So here, the last operation there, we take a cube root, we square, squaring. So we're going to square root both sides. And when we do that, we have to make sure that we include a plus or minus. And we can even simplify that a little bit. Again, feel free to combine a step or two in here if you're feeling comfortable, but make sure you show me enough that I can follow your process. And then the last step will be to cube each side. And you can think about this as cubing all at once, or at this point, if you're more comfortable, you can think about that as a 2 cubed and a -2 cubed. That's really all we're saying, is that we have x cube root of x equals +2 and cube root of x equals -2. It's really two equations that we're just working at the same time to save ourselves a little writing. So our answers end up being 8 or -8. And be very careful, you do still need that plus or minus for even roots, so watch for those. All right, just one more to make sure that you're feeling okay about these. A little bit messier, but again, all you should see is a single variable floating around, so you can just follow your reverse order of operations. Here, the first thing that happens is the inside of the parentheses, if we're talking order of operations. And then we would have the exponent second and the multiplication last. So the first thing we're going to do is get rid of the multiplication using division. And I get x plus 5 to the negative 3/2 equals 1 over 64. I'm going to go ahead and make my next step dealing with the negative exponent. I think it gets really confusing if you try and eliminate all of that at once, but if you're comfortable and you want to use that product property for exponents, you can do that. I'm just going to show you what is a little bit longer way, but also you can really understand each step, I hope. So I'm going to look at that as an x plus 5 to the 3/2. And you can even go further than that if you'd like to. We can make that the square root of x plus 5 cubed. Okay, so the first thing, I do actually like this because it's introducing something that we'll tackle a lot later. If your variable gets stuck in the bottom of the fraction, you need to get it out of there, which means you actually need to multiply both sides of this equation by that cube root of x plus 5. I'm sorry, the square root of x plus 5. I don't even need to write that, do I? Cubed. And the same thing over here, square root of x plus 5 cubed. And if you'd like to clear fractions completely, you could also multiply by the 64 at the same time. And that'll just make sure that you don't have to deal with any fractions in your next step. So on the left, I get to cancel the root, and I'm only left with the 64. On the right, I get to cancel the 64, and I'm only left with the root. So that might feel a little tricky at first, but just play around with it. We'll give it a lot of attention coming up in a couple of weeks. My next step here is going to be getting rid of the cube. So I'll cube root both sides. And that will cancel the cube. And this is actually a nice one. I can evaluate that. The cube root of 64 is 4. And then my last step, I need to get rid of a square root. The inverse operation for that is squaring. I don't know why it's so tempting, but it's really easy, even if people would know better if they thought about it, to just kind of go on autopilot. And I'll see people use square roots to get rid of square roots, and that's not quite right. You want to use the inverse operation. So 16 equals x plus 5, which means x equals 11 is our answer to that one. So they can get a little bit tricky, but there is always one simple thing, and that's that there's a single x, so you can use those reverse order of operations and use your knowledge of what fractional exponents actually represent, and hopefully that'll be really good learning for this section.